Here's a review for second semester. I think we've already gone over that in class, the multiple choice section. So let's start with the first problem in part B. And don't forget, you can use a formula sheet, a one-side handwritten sheet of paper, many formulas, things you want on that for the final exam, that's fine. Okay, so sketch these graphs. So here's the parent graph, goes through the point 0, 1. It's not written down there, but it has an asymptote at y equals 0. So this one is doing two things. So this one is going to reflect it across the y-axis. So right away, it's going to have this kind of a look to it. The asymptote at y equals 0. But this moves it up 1. So you're actually going to move the asymptote up from y equals 0 to y equals 1. And then the point here, instead of being at 0, 1, it's going to be 0, 2. And the graph is going to come down and look something like that. That's the point. I don't require a lot of points on that graph, just the behavior to be correct and the asymptote. Evaluate the expression. So you want to kind of simplify these. So the way I do these is I usually put them in exponential form. So this would be 3 to the x equals 27. Hopefully you know that. 3 to the third power is 27, so x is 3. This one you could move this over first. So 4 times log base 2 up 1/2. But instead of 1/2, I'm going to write it as 2 to the negative 1. And do the same, by the way, this should have been in parentheses. Do the same trick again. I'm going to move that over to the left, so it'll be negative 4 times log base 2 of 2. Hopefully you know what log base 2 of 2 is. It's a property that's just negative 1. So negative 4 times 1 is negative 4. This one, hopefully you just know the property, right? The base is the same, kind of like this one. Log base 2 of 2 is 1. Log base e of e is 1. This one, you could move this up first. I'm just moving it up to that spot. So it'll be log base 5, 45, minus log base 5 of 81 to the 1/2 power is the square root of 81, which is 9. Now we're going to divide. So we're going to write this as 1 logarithm. It's going to be 45 divided by 9. Which of course is 5, so log base 5 of 5, which is 1. Solve these special triangles, so that's 30, sorry, that got moved around a little, which means this one's 60, this is going to be twice that, so it'd be 14, and this would be 7 times root 3. This one is 45, which means this is 45, which means this one is 5 root 2 divided by square root of 2, which is 5. And this one has to be the same length, so it's also 5. Substitution or elimination. Let's see which one looks easier. So I might multiply this one by negative 3. So I'm going to put that right below. So I get negative 9y equals negative 3x minus 6. I'm going to subtract, that goes away, you get 0 equals x squared. Negative 2, I guess I'm just adding those. So negative 2 plus negative 3 is negative 5x plus 4. Hoping this works. Maybe it factors. Maybe 4 and 1, both of them minus. So the solutions are x equals 1, x equals 4. Could just plug those in just to make sure they work. I think they do though. Well, we're not done, I guess, technically. So we've got one of the x values is 1. I don't know the y value. One of the x values is 4. I don't know the y value. So if we plug in here, so we plug in 1 right there. So that'd be 1 plus 2 is 3. I'm sorry, I messed up. So that's 3y equals 3, which means y equals 1. If we plug in 1 there, that'd be 9 equals 1 minus 2 is negative 1 plus 10 is 9. That does work. And then plug in 4 right there. So 4 plus 2, so that'd be 3y equals 6. So y equals 2. So y equals 2 when x is 4. And again, you can plug it in to make sure that works, but I feel pretty good about that. So B times C, this, by the way, is 2 by 3, and this is 3 by 2. So can I multiply? Yes, I can. The dimensions of the answer will be the outside dimensions, which will be 2 by 2. So if I multiply this, I should get a 2 by 2. So I have 1, 2, 3, 4, 1, 2, times 2 there. In the top left, I'm going to have the top row times the left column. So 1 plus 6 plus 15. 7 plus 15 is 22. Left top row and right column would be 2 and negative 8 plus 0 is negative 6. Bottom row left will be 4 plus 3 plus negative 10. 4 plus 3 is 7, plus negative 10 is negative 3. 8 plus negative 4 plus 0 is negative 4. I'm just going to type that in my calculator just to make sure I'm right. This might be in the calculator section, I'm not sure, but I'm just checking it for accuracy purposes. So I'm going to customize on this one. And that was a 2 by 3. So 1, 2, 3, and 4, 1, negative 2 times C, which is 3 by 2, which is 1, 2, 3, negative 4, 0. 22, negative 6, negative 3, and positive 4. So this should be positive. I messed that up. That would be 4 times 2 is 8. Sorry, 4 times 2 is 8. 1 times negative 4 is negative 4. That's positive 4. 8 minus 4 is 4. Yeah, that's correct. E minus B should be a little easier. So we're going to do this one minus this one. I'm just going to write the answer because we know what form. 3 minus 1 is 2. 4 minus 2 is 2. Negative 1 minus 3 is negative 4. 0 minus 4 is negative 4. 2 minus 1 is 1. 5 minus negative 2 is 7. Should be right. Find the inverse. So there's a little pattern to this. I think the formula is 1 over determinant times the kind of mixed up matrix. I think you take the A and D, so it'd be D and A, and then opposite of B and opposite over C. So in this case, the determinant is negative 9 minus negative 8, which is negative 1. Okay, so I have 1 over negative 1 times 3 and negative 3, 4 and negative 2. Everything's going to change sign. 3, 4, 2, sorry, 3, negative 3, negative 4, 2, and 3. I think that's the inverse. Let's just see. So if I type in a 2 by 2, negative 3, negative 4, 2, 3, 3, negative 4, 2, 3. I got it. Right, just checking my work as I go. I don't have my answer key, I'm just making it as we go. Graph the parabola, label the vertex, focus, directrix. So right away I can see that H is negative 1 and K is 3. So negative 1, 3 is my vertex. You can see this one's opening down. So the directrix has to be down C units from there. So C equals 1 over 4A. 4A would be 4 times negative 2. So C is negative 1/8. So go down 1/8, go up 1/8. So that'd be Y equals 3 1/8, or 25/8. this point would be -1, 2 7/8. That would be the focus point. And then I would go 2, so this distance is 2c in each direction. So a total of 4c for the focal diameter. So if I go twice times -1/8, so that'd be 2/16. No, let's see. Yeah, 2 times 1/8 is 2/8, which is 1/4. So I go 1/4 to the right, 1/4 to the left, make my points, and draw my parabola. For that parabola, so right away, like if you just kind of sketch it out, center is 2, 3. It's the center. The vertex is 0, 3. So that's a vertex, which means there's going to be a vertex over there, which means this guy's looking something like this, right? So this is a horizontal one. I need to figure that out first. So it's going to be x first because it's horizontal. X minus, the center is 2, so x minus 2 squared, minus y minus 3 squared, that's my k. From the vertex to there, the center is a distance of 2, so a equals 2, so that would be 4 here. And then this one, the focus to the center, so that's 5, 3, so we're up there. That's a distance of 3 units away from 2, 3, so it's 3 units, so that's the c distance is 3. And I think the formula is c squared equals a squared plus b squared. So c squared is 9 equals 4 plus b squared. So b squared equals 5, so b equals square root of 5. So square root of 5 squared is 5 equals 1. I think that should be correct. This should be a lot easier. So h and k are these 2 points. This looks like a distance of 2. That's my b value shorter. And this looks like a is 5. So the formula would be x minus -1 or plus 1 squared, y minus 2 squared. Horizontal distance squared below, vertical distance squared below the y. So the formula, if you don't have it, is x minus h squared. So x minus -2, which is x plus 2 squared, plus y minus 4 squared equals radius squared. That radius looks to be 3, so that'd be 9. List every element, so this would be heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. Getting exactly a number larger than 3 and tails. So I want tails and a number larger than 3. 3 out of 12, which is 1/4. So 1/4, I'm doing my work for this one here. Okay, find the intercepts, the holes, etc. So right away I know there's a hole where the x value is -2. I don't know the y value yet. My new function would be r of x equals 2 times x minus 1 over x. So right away I see there's a vertical asymptote at x equals 0. I see, let's see, so let's find the intercepts. There's no y-intercept, it's asymptote there. X-intercept, we're going to plug in 0 after we canceled out, so we get 2 times x minus 1, so x equals 1. So it does cross the x-axis at x equals 1. Not sure which way it goes. Maybe it does this, maybe it does this. I'm not sure. So to check, I'm going to plug in 2. So if x equals 2, the y value, if I plug into this guy, would be 2 times 2 minus 1 over 2. So that's 2 minus 1, which is 1. So 2, 1 is right there. So it does look like this graph is kind of doing something roughly like that. I'm not sure exactly what it looks like. This one's weird up here, so I'm not sure if it's in one of the quadrants. I'm going to plug in -1 to see what happens here. So I get, if I plug that in, I get 2 times -1 minus 1 is -2 all over -1. So I get -4 over -1, which is +4. -1, 4. Whoops. Right there. And just these numbers, just ignore them. They seem to be not relevant to this problem. It does look like it probably does something like this. I don't really know what it does. Maybe they just should probably plug in more points. Let's graph it and see how close that is. Probably should plug in more points just to see what's going on there. So 2 times x plus 2 times x minus 1 over x times x plus 2. Oh, I didn't see the horizontal asymptote. So there is a horizontal asymptote there. I should have recognized it. I don't know why I didn't think of horizontal. So you think it's the same degree? So we have this. So there's definitely a horizontal asymptote. Let me. There we go. I don't know why I didn't draw my horizontal. So I didn't see it at first. It would have helped my whole graph for sure. So something like that. And then this one was up above, I believe. Something like that. Let's just see if that matches. Yeah, I have to remember about horizontal. See, it's been a while. We haven't done horizontal asymptotes. So the 3 cases are for horizontal asymptotes. So if it's same degree, which this one was, you divide the coefficients. So x first, x the first, so you divide 2 divided by 1. So that's, you divide coefficients. If it's top heavy, so if the degree in the top, like x squared over x, there is no horizontal asymptote. If it's bottom heavy, it's always the same. It's always y equals 0. So those are the 3 cases. So you definitely should be looking for some horizontal asymptotes on those kinds of problems. Sometimes you just forget. I know the transformations of exponential functions. So this one, it's doing a couple things. Wow, this is a really tough one. I can't believe I gave you one this tough. So I might want to consider factoring out that negative there. So this would be f of x equals 2 to the negative x minus 1. I think that'll help us see the problem a little easier. So the negative is going to reflect it over the y-axis. So let's start with that. So it kind of does this. The plus 1 or the minus 1 is going to move it to the right. The plus 3 is going to move it up. So I'm going to the, this was the point right there at 0, 1. I'm going to move it to the right 1 and up 3. So now it's at 1, 4. The asymptote was at y equals 0. Now it's at y equals 3. I know those numbers are confusing there. Just ignore those. I didn't use them. So y equals 3. And the graph is, I guess I could figure out the y-intercept. Plug in 0. You get 2 to the first plus 3 is 5. 1, 2, 3, 4, 5. Something like that. So our graph looks roughly like this. Exponential decay. Counting allowed. Present value, so 10,000. So a of x, or a after 30 years, in this case, would be the principal times 1 plus r, which is 0.04, divided by n, which is monthly 12, to the power of 12 times 30. That's a 12 right there. Then you just put it in your calculator. At that point, it's just plugging in a formula. So 10, 1 plus 20 over 4 divided by 12 to the power of 12 times 30. So this is equal to, let's see, let's get that again. So 33,135. So more than doubled in that 30 years. That's good. Tripled, right? Went over tripled. So really nice problem there. Find the domain. So in this one, you want to make sure that this is, we really want that to be 1/2 x minus 5 has to be greater than or equal to 0. We don't want to take the, greater than 0. So I don't want it to be equal to 0. You can't take the log of 0 or negative. So just solve that. You get 1/2 x is greater than 5, multiply by 2, and you get x is greater than 10. And that would be the answer there. Sorry, that was a little sloppy. Use all signs, find all possible triangles. So let's kind of draw this out over here. So a is 30, little a is 10, little b is 16. So I'm going to solve for b first. So sine of b over 16 equals sine of 30 over 10. So 10 times sine of b equals 16 times sine of 30 divided by 10 divided by 10. Then we're going to take the inverse sine of that. So inverse sine of that. Let me just type in the calculator at that point. I could have stopped before and done our test. So this was, I'm guessing this might be ambiguous. We'll see what happens here. Okay, so inverse sine of 16 times sine of 30 all over 10. So this is equal to 53.1301. And let's see, we were given side angle. That's bad word information. Could that make a second triangle? Well, let's check it out. Given information is the same. So the supplement of 53, find that would be 180 minus that 126.87. 126.87. That does make a second triangle. So you've got to continue solving. So plus 30, 180 minus that. So this one's 23.1301. The other angle there would be that plus 30 and 180 minus that is 96.8699. You've got to use law of sines one more time for each one of these. Let's do the first one. That'd be sine of 96.8699 all over, let's call this little c, sine of 30 over 10. So I'm going to do this a little faster than the last one. So this will be c times sine of 30. Let me go faster than this. 10 times sine of 96.8699 divided by sine of 30. So I'm going to type that in my calculator. 10 times sine 86.99 divided by sine of 30. So that seems reasonable, I think. 19.9724 is this one. And then we do it one more time over here. So this would be sine of 30 over 10 equals sine of 23.1301 over little c prime. Nice ring to it there. So little c prime is going to equal 10 times sine of 23.1301, all divided by sine of 30. So let's see, I'm going to retype that one, except 23.1301. We get little c prime is 7.85641. There we go. A lot of work. Use a lot of cosines. So if that's the thing we're finding, it's going to be b squared here. So b squared equals a squared plus b squared minus 2ab times cosine b squared equals a squared plus c squared, minus 2ac times cosine of big B. So this will be b squared is 14 squared equals 20 squared, or sorry, I guess I could put 12 squared there. 12 squared plus 20 squared minus 2 times 12 times 20 times cosine of x, or b there, whatever you want to call it. So then we're just going to solve that. So I might get my calculator out for this one. 14 squared minus 12 squared minus 20 squared. I got those to the other side by subtracting. So we get negative 348 equals negative, let's do that in our calculator. So that's going to be negative 2 times 12 times 20, negative 480 times cosine of x. We're going to divide negative 348 divided by negative 480 is positive 0.725. So cosine of x equals 0.725. Okay, so we're going to do inverse cosine of 0.725. And we get x is 43.5312. I guess that's degrees. How many solutions will there be? So let's just kind of like draw it out. So b is 30, b is 16, a is 7. So that's side angle. That's the biggest case potentially. So we're not sure what's going to happen. So we're going to set it up and solve for the first angle. So sine of 30 over 16 equals sine of a over 7. So I get, just solving this kind of fast, sine of a equals 7 times sine of 30 over 16. And I'm going to just go ahead and type that in to see what I get. So I get, let's see, 7 times sine 30 divided by 16. So this does have at least one triangle. So I'm going to take the inverse sine of that. So I get A is 12.6356. Let me go ahead and do 180 minus that. It's 167. So if I drew a second triangle, so this angle is what, 12.6, basically. I'm just rounding there. and this other one would be 167.4. 167.4. So if this is 30, is that too many degrees for a triangle? That's more than 180. There's no second triangle. There's only one triangle here. So there is that first one. That's a triangle. That'll work. We could solve that one, but not the other one. So Kramer's rule uses determinants to solve. This is one you just set up. So x equals the determinant of the coefficient matrix should just be 5, 6, -4, and -5. And up top, instead of x's, I'm going to plug in that 2 and 1 right there. So this is going to be -25 minus -24, which is -1. This is going to be -10 minus -4, which is -10 plus 4, which is -6, which is 6. I should get 6 there. Y equals, for this one, I know my denominator is -1, so I'm not going to worry about it. This is going to be 5 and 6 are still there from the coefficients, but I'm plugging in 2 and 1 here. And so in the numerator, I get 5 minus 12, which is -7, over -1, which is 7. So that should work. If I plugged it in, 35 minus 24, plug that in there, that's 30 minus 28 is 2, that works. 36 minus 35 is 1, that works. So that is the ordered pair. I would write it this way, 6, 7. So it takes 3 hours to travel downstream with the current. So it's kind of going downstream with 3 miles per hour. This is downstream. The return trip this way takes 4 hours. So 4 hours. So we've got like, the distance is really the same here. So distance equals rate times time. So the rate times time of the first trip equals the rate times time of the second trip. So rate times time of the first trip equals rate times time of the second trip. So I know the rate on the first trip was 3. But it's downstream with a current. So I'm going to call it x plus 3 was the rate. We don't know how fast the river was going. Times the time, which is 3 hours. And then the return trip, the time was 4 hours. And the rate I guess, so this is going to be rate or x minus 3. So the current is like your rate minus 3 is what it is, times the time of 4 hours. It makes sense it's going to take longer coming back, right? So this is downstream, this is upstream. Let's double check that makes sense. I think that makes sense here. So this would be 3x plus 9 equals 4x minus 12. So x equals 21. So what is the boat speed? So it's going 21 miles per hour minus or plus the current, and then 21 miles per hour. Does that make sense? Yeah, I mean, that makes sense. That's going fast though. I guess maybe it's a speedboat. I was thinking canoe there for a second. It could be a speedboat. Graph the ellipse. So I guess that would be, what is the speed? Miles per hour. Graph the ellipse, label the vertices and focus. So the center is going to be -1, 2. So -1, 2. Horizontally, I'm going 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 to the left. Vertically, I'm going 4, 1, 2, 3, 4. 1, 2, 3, 4. And it's ellipse, so something like that. The longer axis is this one. It's horizontal. So a distance of c units away. So c squared equals a squared minus b squared, I think. Hopefully I'm getting that right. So c squared equals 25 minus 9, which is 16. So C equals 4, so I'm going to go 4 to the right, 4 to the left, make my focus points. That focus would be at plus or minus 4, comma 0. So 0, 0, horizontally, vertically going up 3, down 3, horizontally to the right 4 and to the left 4. It's vertical, so these are the vertices. Draw the dot box, connect the lines. So it's coming off that one, and that one, and that one, and that one. Panels are given to first, second, and third. There are 8 runners. How many different ways? So I just care about the top 3 spots. So 8 times 7 times 6. Get your calculator out. There are 336 ways that the medals could be awarded. Order is important on that one. How many different combinations? You can't order 2 of the same veggies or meats, that kind of thing. So 1 meat, 2 veggies. So there are 5 meats. You can choose 1 meat and 2 veggies. Okay, so 1 meat and 2 veggies. So 1 meat is 5, right, times. And how many different ways can we choose the veggies? So that would be NCR. So that would be 10, whoops, 10, choose 2. Okay, so because order is not important on that one, so it'd be 5 times NCR 10, comma 2. 225 different ways to order that. Kind of a tough one. I think that's right though. Blackjack consists of 2 cards. What's probably getting 2 jacks. So in the first one, it's going to be 4 out of 52. And then the second draw is going to be 3 out of 51. So that's the key. So you're doing a slot method there. Four divided by 52 times 3 divided by 51, which is 1 over 221. Wow, it's not very likely, I'd say. It's pretty unlikely. Exactly 3 of them. So this looks like binomial. So what's your P, your Q, your N, and your R? There's only 2 outcomes. So 60% I want them to favor, 40% are not in favor. 5 voters are interviewed, and I want to get exactly 3 of them. This would be NPR, so this would be 5, choose 3, times 0.6 to the R, times 0.4 to the N minus R. I think I just typed that in my calculator at that point. NCR 5, comma 3 times 0.6 to the third times 0.4 to the second. 0.3456. Sorry, got a little printed a little funny here. So know how to do long division. So let's just do long division here. So x squared plus x plus 3. 3x to the 4th minus 5x cubed minus 20 minus 0x squared minus 20 or plus 0x squared minus 20x minus 5. So I put a 0 in there just to keep us honest there. That's kind of a sneaky move there, but I like it. So this one would be 3x squared. So 3x to the 4th, that's good. Plus 3x to the 3rd plus 9x squared I'm subtracting everything there. So don't forget to subtract. So that'd be negative 8x cubed minus 9x squared. Bring down the 20x. Now it's going to be minus 8x minus 8x squared minus 24x. Don't forget you're subtracting everything there, so it's going to be adding 8, so that's negative x squared plus 4x. Don't forget to bring down that next term. This would be minus 1, negative x squared minus x minus 3. Subtracting everything, so that'd be 5x minus 2. So I get an answer of 3x squared minus 8x minus 1 plus a remainder of 5x minus 2 over the divisor of x squared plus x plus 3. Rational zero theorem, factors of this term, so 3 and 1 divided by factors of the first term, which is 1, all the possibilities plus or minus, so plus or minus 3, plus or minus 1, those are the only two fractions I get there. So there are 4 possible answers. Work backwards, so 4 and 3i, so the other solution would have to be negative 3i because there's 3 solutions there, it's a cubic. And these always come in pairs, so that's called a complex conjugate. So this would be x minus 4, this p of x or some f of x or something, times x minus 3i, that's the second one, and then x plus 3i. I'm going to FOIL these together first. So I'm going to leave that x minus 4 for just a minute. This will be x squared minus 9i squared, which is really x squared plus 9, because that's negative 1. So then we get x squared x cubed minus 4x squared plus 9x minus 36 equals p of x. And know your ACT, SAT stats. Any of those questions we used, homeworks, reviews, tests, are fair game. I'll probably choose one of those, to be honest. Some of those, not just one, but a number of those. That is your review. Sorry it took